Hello and welcome to today's video. So today we're going to talk about transformers. And as you can see, I'm a fantastic drawer. And I shouldn't just be a physicist, science teacher, I should be an art teacher. But transformers comes into two areas at GCSE, but also is linked into A-level as well. At GCSE you might look at it when you do mains electricity and also when you look at the national grid. So we have to know what are transformers and some calculations associated with transformers. So what are transformers? Here we have a very simple transformer, and what we'll have an alternating current input. Now this will produce a magnetic field through here, which then is transferred throughout the iron core. It gets transferred throughout the iron core, which will then induce an AC, an alternating output here. So it will induce, and that's a word that we have to use when we look at transformers. So it's a way of either stepping up our voltage or stepping down our voltage. Now we'll step up our voltage when we go from the power station to the national grid. So that's when we step it up, and we'll step it down a bit later on when we go from the national grid before it gets to our homes, and it will go down to around about 230 volts, but even smaller than that, because like your plug phone chargers will actually have little transformers in there as well, and that will take it even down even further. So they're really important, and there's a video on the national grid that I've done and uploaded. See if you can find that on the Mastering Physics channel. So we've got here a simple transformer. Some other key things we've got to know. We've got our primary coil here, and we have what's called the secondary coil here. Now, if there are, like there are here, if there are less coils on the secondary, it means it is a step down transformer. But if there are more coils on the secondary, it will be a step up transformer. So what calculations do we have to know? Well, potentially we've got to be able to use this calculation here, which is calculating the output potential difference. Now let's just get rid of this a second. So we've got a simple transformer there, and let's look at our calculation that it's going to be Vp divided by Vs, which is the voltage in the primary, that potential difference divided by the potential difference in the secondary. And that is going to be equal to the number of turns on the primary and the number of turns on the secondary. Now, a simple way of doing this is we can use our cross multiplication method, whichever one is missing. All right, so big up on your cross multiplication. All right, that's really important for this. But also, if it's simple numbers, we can also look at ratios. All right, so we can look at the ratios as well about what's what. So for a step-up transformer, the voltage on the secondary is going to be greater than the voltage on the primary, and the number of turns on the secondary is going to be greater than the number of turns on the primary. So we have here a simple transformer, and let's just say on our primary, all right, we're going to have 2 turns. Right, and we want to work out the number of turns on our secondary. We know that on our primary we have 10 volts, and on our secondary, let's say we've got 50 volts. So this should automatically tell you, right, that because of this number, 50 is greater than 10, it's going to be a step up transformer, which means we need more coils here. More coils needs to increase here. So let's put those numbers into our equation. So if we look here, the voltage on the primary is going to be 10, and that's going to be divided by the voltage on the secondary, which is 50. And that's going to be equal to the number of turns on the primary. We have 2, but we don't know the number of turns on the secondary. So we can do our cross multiplication. 50 times 2 divided by 10. All right, so 50 times 2 is 100, divided by 10, that is equal to 10. So we know we're going to have 10 turns. And you can always double check that for a couple of ways you can do that. We know that 10 divided by 50 is 0.2, and then do the same, so that should be equal to 0.2 as well, and 2 divided by 10 is also 0.2. We can also see that the ratio here from 10 to 50, that's also gone up by 5, so we also have to times that by 5 as well. So that's how we look at calculating the potential difference, and we can do that for any method for any of those missing numbers on there. And then we need to know, all right, about efficiency. Now, transformers, they potentially they are going to lose a little bit of thermal energy. It's be transferred to the surroundings, so they're not always going to be 100% efficient. We'd like to think they are. So we'll assume 100% efficiency here, and then we can use this calculation here. Now we should know from previous bits of electricity that power is equal to potential difference times current. So when we look at our transformers, our secondary and our primary, it's V times I should be the same, should be the constant for both of them. So let's say in our secondary coil that we had 5 volts and we had 8 amps. Now we want to work out the primary potential difference. We don't know that, but we do know the current over there is going to be 2 amps. Now 5 times 8 is 40. Alright, so then we have to do 40 divided by 20, which equals 20 volts. So we've increased that by 4, and we've divided that one. So we've increased this one by 4, and we've divided that one by 4. And this works out from here for our step-up transformer that our voltage on our secondary is more than our primary, but the opposite will happen to the current. And then, so the opposite will happen completely when we go from primary to secondary. So that is the basics of transformers. I'll do another video soon with some more practice calculations, but in the meantime I hope that helps, and good luck.